Okay, so lots of P's right here. P4, 4 P's to be exact, the Private Periodic Payments Protocol. Basically, yeah, reoccurring subscriptions with privacy. And to introduce myself real quick, I'm Liz Steininger from Least Authority, CEO and Managing Director. And yeah, so we care a lot about privacy. Okay, yeah, so Least Authority. I'll tell you a little bit about ourselves and why I want to work on this. But yeah, so we believe that people have a right to privacy. We help to do this by helping others to improve their technologies. We do this through security audits, helping to make sure that the personal data that is being used in other people's technology is being securely held and transferred. And then we also build our own secure storage product and just generally contribute to secure software, open source software that has a security aspect to it. So we focus our efforts a lot on usable secure technology, that it's great to have secure technology, but it's even better if people can actually use it. We also try to focus on privacy by design, that bringing the thoughts about privacy and protecting people's data earlier into the process of software development. And we like to focus also on decentralized tools that are also open source. So these are things that we just, we like to help out projects that are doing these things, and we also like to do these things ourselves. Oh, there we go. So we have a problem. You know, this is how it starts, right? People have problems, and then we want to solve them because we're technologists and we like to solve problems. So we don't like to collect personal data because we care about privacy. But we need to collect it for payments processing. And this is our problem. And it's pretty difficult for us to run a subscription service for secure storage and also accept payments. And so right now, we use Stripe, and we collect personal data basically only for the payments processing, and we don't need personal data to store people's data. And so, yeah, this presents us with a really interesting problem where it's just the payments that we're struggling with. And that's complicated by the fact that it's a subscription service. So, yeah, the reason we're all here is because we think that the current financial system is outdated, right? Cryptocurrency, talking about how blockchain can also change fintech. This is what brings us together at events like this. And then we also do believe that we must defend our own privacy if we expect to have any. So there's a privacy aspect here too. So collecting payments through these online payment processors like Stripe is pretty convenient for us, but it is going against what we want to be doing in this world. So in this cryptocurrency world, we do have to remind ourselves that privacy matters. And so how do we work around this particular problem? We wanted to see if we could come up with a way to accept private payments for our subscription service that also protects privacy. So that brings us back to the topic of privacy by design. So we thought, yeah, hey, we need to do privacy by design if we're thinking about solving this problem, right? We have this great opportunity to disrupt the status quo, to do something different and better than Stripe, and to incorporate privacy from the beginning of our designs. And we have these grand visions of, all of us here are working on some project or watching some projects that have grand visions of changing the world. So if we want to change the world, we should also think about how we want the world to be and if privacy is something we value that needs to be incorporated in the beginning. We don't want all of our subscriptions to be public knowledge. We don't want to leak data in the process of paying for these subscriptions. And we also don't want to leak things that could be correlated with other data that could then become personal data about us. So a good example of how we like to think about this is HTTP and HTTPS. We all built the internet with HTTP. Now we've switched to HTTPS, and we realize that that's better. How about we do that the other way, like start with the HTTPS now? And so that's what we are trying to think about with how we approach this. So to talk a little bit about, just quickly, about what we are trying to add the subscription service for is is our S4 product, which is Simple Secure Storage Service. I'm not trying to do marketing or anything, but it's important to understand the security principles that are behind it and how it functions, because this really ties into making having private payments be so important to this type of particular system. And so it does incorporate, it's basically capability-based security, and it has client-side encryption. You have to have the capability to access it. There's no logins, there's no passwords and things like that. And so because of that, we don't have any personal account information on people. There actually just isn't account information in general, which is nice. And so the ciphertext is stored with servers that we take care of. The servers are what I like to call stupid. But they don't know what they're storing. They just have shares of ciphertext. And they don't know, they know enough to like put it back, the client side is what puts it back together and decrypts it, and the servers know nothing about this. So this is good security properties, and it has good privacy properties. So yeah. And then we have the payments where we're using Stripe. Really not cool. So payments by subscriptions. This is important. We need to accept these payments for a subscription business model. And to like go over that real quick, it's just that these payments need to repeat at specific intervals. These are, and they need to be related. There are many variations on how merchants would prefer to manage these subscriptions. It can get kind of complicated, and they want to offer various options for the plans, maybe different periods that they need to repeat. And all of that, we want to try to make sure that there's not a relationship being built that could then become data that you could look at to then deduce who somebody was based on their behavior of paying the subscriptions. So there's a privacy concern there too. But for us, it really does seem that like the subscription business model is a good fit for what we're trying to do. So yeah, this is why we have this problem. And blockchains right now, most of them do store data publicly, and most cryptocurrencies have personal data in the transactions, so we need cryptocurrency with privacy. And you guys have heard of Zcash. So we started looking at Zcash because we know that it's got these privacy properties in the transactions that we would like, the Zcash, the shielded transactions. And so we also, as a side note for disclosure, Zcash company is a sibling company of ours. But yeah, so we've been talking to them about this, and this is just a quick rundown of what Zcash is. I won't spend time on it because I think somebody else did earlier, somebody from the Zcash team, and they're here. But yeah, so the shielded transactions offer us a particular type of zero knowledge proof called zkSNARKs, and when there's a Zcash transaction, there is an existing string of data that the sender of the transaction provides, the zero-knowledge proof, along with the encrypted transaction data, which provides properties of the encrypted data cryptographically. So this assures ownership over the spending key and allows for verification for the transaction is valid, while preserving privacy of the transaction details. And the sapling release that's coming in a few months will also make this faster to use. So we've been looking at that goal for ourselves, about like how can we implement something that's actually usable around the same time as sapling, and that's usable today because we want to use it now. So yeah, so now it's expensive to make things private and it's cheap to make things public, and we need to change that. One of the current, sorry, I lost my net place. Okay, now into the difficult part of putting all the pieces together. So using cryptocurrency for subscriptions, this is getting into the real problem that we have. So one of the current uses of Zcash shielded transactions is to have people prepay for subscriptions. This is out there being used by some people, and this works really well for service offerings where you can just shut down the service, but this doesn't work so well for us because then we're left with a bunch of ciphertext that belongs to somebody, and we're not quite sure what if they want to pay a month later or something. So it puts us in a weird business situation that we wanted to see if we couldn't work around that too. And this doesn't work, and this also is, another option would be to use something like smart contracts for managing subscriptions, but yeah, the privacy problem is there too. And then, and another option is the post-paid charging for use, but this also has the same kinds of problems as like the prepayment. And then there's issues around periodicity. So basically the recurring nature of these payments. We need to have this ongoing transactional relationship. And so some of the problems that we started looking into with this was the pre-authorization. Cryptocurrencies lack any semblance of pre-authorized payments by design. So this is definitely something that we have to solve. And then ideally pre-authorization, and also pre-authorization is bad because we ideally want to keep the power in the hands of the users. And this is why cryptocurrency doesn't work like that. As for data standards, the cryptocurrencies share no common language or protocol, and that's why some people are talking about like cross-chain transactions and ways to have that. But especially true in this case, there's no notion of billing period, due date, grace period, late penalty, and stuff that you would see in other subscription systems. And using cryptocurrencies for subscriptions imposes an additional financial risk on customers and merchants about price volatility right now. So we thought, how can we control for these issues in designing something? And so looking at what we needed to actually design, we looked at the required events for it. So a subscription service has to have sign up by the customers, they have to do the creation, and they need to check the payment status. There needs to be a way also could be confirming that the payments have been made and communicating that next payment, so that reoccurrence of the payments is what needs to be there too. And this is what we thought is the list, is the MVP, like the minimum viable product to have any kind of protocol that would help for reoccurring private payments. So these. So this is a diagram that we came up with about the sequence of events that has to happen, looking at those things that have to happen, and these are the parties involved. And so we have the customer, the client, in our case is GridSync, but this could be a client on the machine. I think you guys can probably read that it says customer, device, and external systems. And then the wallet that you need to have to utilize ZCASH in this case, and the secure network Tor. And then the merchant would be us, and the payment network, again, of zkSNARK. And so this is basically the steps that have to come. And the first part is not so it's kind of interesting, but it's how we really make sure that this loop at the bottom happens without revealing any information that any data that could be used to see any patterns which then could tell you who the person was. Because we have other data, and so if we could correlate that data, we could start to figure out who somebody was, and we don't want to do that. So we need to make sure we do this in a way that's anonymous along the way. So yeah, I'll go through it in some more detail. So you would visit the Tor-based webpage, and this is where the user would go and say, yep, I want to sign up. And they generate a code for themselves. And this page doesn't have to be very fancy. It really just has to generate the code. And then the code is sent back to them. And then they put the code into their client. And that code then talks to least authority. And least authority's server says, okay, great, you need configuration information to connect to our network so that you can store your data. So we send that Tahoe config and the first signed invoice back to them. And so I'll talk in the next slide about what that invoice contains, but that's the data pieces that we need to add to these transactions to know about how the subscription is going to function and how it's going to, like the period of time and stuff. And then they make a payment. Oh, and also we want to sign it for security purposes too. And so we send that signature over initially. And so then they make the payment to a receiving address, which we have put in this initial send of data to their client. And so they know that they need to go to their Zcash wallet and make the payment, and that goes onto the Zcash network, where we're monitoring the Zcash blockchain, the network, for that payment to appear. And when we see that payment appear, then that's the key for us to generate the next invoice for them. And we basically just update this invoice information to reflect the next state. So your next payment due, basically. And that could be like any period that is defined with the data. And this we serve on, and in this design, we said, okay, we can serve it on a Tor-based web page, because this way we don't know who they are when they go visit the web page. Because if we put it on our website or any kind of centralized place, we could get their IP address, so then we could find out who they are. There's other problems too. So we thought this way we don't know who they are. And so they just go to this address, and they get the data that they need from us. And so, yeah, their client then knows to check for the invoice information on this page, and then maybe serve it back to them in a nice UI or something. Yep, so it notifies the customer of this invoice information, and that's on the client side, so that that periodicity that's happening is on their device, as opposed to out in the blockchain or in some centralized repository where it could be mined. And so, yeah, then they make the next payment when they're ready. And then this can be adjusted. So this is where we're thinking right now of how this could be designed and how this could work. And we know that some of this could be done a little bit differently, but this is something that we could actually build in the next few months. Actually quicker than that. It's not a whole lot of work to do this, but figuring out how it works all together is the hard part. So this is the invoice data that I mentioned. It needs to include a version number, also payment address to receive funds. So this would be the Z address that people need to pay us at. And then the human-facing subscription description, just so they know what they're paying for. Subscription provider public key. This is so that they know that we are who we say we are and that they're paying the right people. And then the payment details, and this is about the subscription. So the time period of the subscription, the price per that time period, the maximum number of payments acceptable, so if they want to pay ahead, and then also payment due date and time. And this is what we think is the minimum data that we would need in order to process this. So earlier you saw some other stuff. Again, we want to preserve privacy, and we want to implement something that has a protocol that enables the customer to pay for subscriptions without intentionally or accidentally disclosing additional information to us or unnecessary and personally identifiable data to either us, the merchant, or any third party, such as email providers, banking institutions, or anybody else watching the network. So every event in our sequence is an opportunity for data to be gathered and be connected back to who we are. And so we wanted to make sure that every event that was happening, that there was some privacy-preserving features there. And so Tor for anonymous web browsing, this allows the subscriptions to be discovered without revealing the user's identity via browsing. And to note, this could also be replaced with other secure and anonymous options, but this is what we chose to use right now just because for an initial implementation is because it works now. But I'm sure there's people designing really cool other things out there that we could substitute for this, but we just want to have that privacy feature. And then the Zcash shielded transactions to avoid disclosing transactional data on the blockchain. And again, you could probably re-implement this with another blockchain that had privacy protecting features. Yeah, we just say that when swapping these pieces out, that we would need to reevaluate the whole privacy implications and the security risks of the whole system. So a quick mention for related work. There's Bitcoin BIP70, which talks about subscriptions, but not reoccurring ones. And this is not an exhaustive list of related efforts, but I just wanted to put that out there in case anybody wanted to look at some of these related efforts. And then there's probably some that I missed too. And then there's Ethereum. There's some discussion around subscriptions there too. And there's things like Lightning Network and Bolt for Zcash. And these all are things, different efforts that people are making in the subscription space, but not necessarily with so many privacy features. So our next steps are to implement this on S4 for ourselves, and along with the sapling release, which will make things faster. And then this will give us an end-to-end privacy solution for our file storage system and the payments that people make to us. In this end, this isn't the end solution for us. We surely could build cooler stuff, but we just saw this as like, how could we prototype something really fast, and how could we design just the basics, and we could build really cool, much more interesting things on top of it, but we wanted something functioning as soon as possible. And yeah, we would like to facilitate the development of higher level applications like user-facing wallets, merchant-facing payment frameworks, and stuff that utilize private periodic payments also. So my calls to action for you guys is to contribute to the development of this type of work, talk about the work and raise awareness, and implement it, steal our ideas, send us your ideas, send us your thoughts and feedback, and see how far we can take these kinds of concepts forward to have end-to-end privacy for people, not just privacy in pieces. And I have to give credit to the creators of Tahoe-LAFS and the creators of P4. It wasn't just me. So, I'm done. I guess, questions, sure.